Hi, my name is Matt Walker, and this is a demonstration of the G-SMS, or Green Soil Monitoring System, embedded system device for the EECS 3215 course final project. My device is an automatic greens soil moisture monitoring system, and what it does is it takes intermittent values or readings of soil moisture, and it will update a LED and store the value to the device. The purpose of this device is to provide greens workers at golf courses with a tool to shorten their morning duties when it comes to managing their greens. Hopefully with this tool, they will be able to monitor their greens more effectively, keep them in better care, and increase the amount of time they have for other duties during the day. So for a short demonstration of how the device works, I will showcase some of its features. First off, you can see the source code here. I will scroll through it. Now, the soil monitor is currently plugged in and powered. I am in debugging mode. And you can see inside this soil right now, which is rather dry, the monitor is displaying a red LED. This tells us that the soil is rather dry. And if I want to request a reading of it so I can see what the exact value is, I can just push the button on the side. It'll tell me that it's 276. So I actually have a debugger thing set up in here so we can see that it is currently attempting to display the value, and it'll hold there until I resume. And you can see that after a set amount of time, the display turns off. This keeps the display from using up too much power, as we desire this device to last for up to a week. So now with the breakpoint removed, I push the button, you can see it displays for a short time and turns off. So, if I take this spray bottle here and I wet the soil by the sensor, and we wait. For demonstration purposes, I have set the device to take a reading every 10 seconds. You can see now that it has switched to green to indicate that this soil is humid. In practical applications, the length of the sensing periods would probably be reduced to about an hour. Of course, it would be up to the team who decides to use it on how long they would want to make that delay for, to give them more or less readings throughout the day. So if I take a second reading now, we can see it's at 2,520 there at the end, 2,512. And this tells us that it's very moist soil. So just to kind of go in depth further, I am currently using a prototyping board with the wires out, and it is storing the data that it reads onto the board. This is because I experienced some difficulties when manufacturing the device. The power boost shield that is controlled by a lithium-ion battery actually exploded, and I was unable to get a replacement due to the current ongoing COVID-19 pandemic. And similarly, my SD card reader also broke. So those two pieces, unfortunately, were unable to be included in this first version of the prototype. However, in later versions, I would like to implement them. And for that reason, I left everything on a breadboard so that I could, after it's all done, get the parts and finish the whole thing together, at which point I plan to solder it fully with the iron. And that's about everything for this device. It's rather simple, but it is power efficient, it is cost effective, and it will provide a valuable solution for golf course owners who wish to take care of their greens better. Thank you very much.